Hi, hello, this is your Lucky sir. Crystal field theory in the tetrahedral splitting. You can see our old video, earlier video, that is about octahedral splitting. Now we'll go with tetrahedral splitting, how it is going to be. If you have seen that, it is very clear to you. Otherwise, I will explain from the beginning, no problem. These five are degenerated orbitals. Okay, now I am writing here simply degenerated orbitals. Degenerated orbitals means having equal energy. Now what happens is, in spherically symmetrical field means ligands are coming in all directions. Spherically symmetrical field means ligands approach in all directions. When ligands are coming in all directions, all orbitals energy will be increased. So we are taking little above. It has no practical use for us. Don't worry for this. Now it will split further. Tetrahedral splitting, we are saying. Tetrahedral splitting means coordinate number 4. When coordinate number 4 is there, it will split in this way. 3 orbitals are going up, 2 orbitals are coming down. These 2 orbitals are called E orbitals. There we said EG, here only E, and these orbitals are called T2. Z word we have removed, E and T2. Why like this? That's the question. See, as we know, d orbital shapes are like this. This is dx square minus y square, and this is dz square, and dxy, dxz will be like this. xy, yz, xz will be like this. Now, when coordination number is 4 and tetrahedral splitting is there, ligands approach. This is the most important one. If you understand this, that things will be easy. Ligands approach between the axes. Now, which orbitals are present between the axes? These are present between the axes. dxy, dyz, dxz. That's why their energy increased. This is dxy, this is dyz, this is dxz. Comparatively, these will be having lesser energy. Dx square minus y square and dz square. Exactly opposite like octahedral splitting. In octahedral, ligands approach along the axis. Here, ligands are approaching between the axes. Things will be same. Now, for every electron entering into the T2, the energy will be increased by plus 0.4 delta T tetrahedral. For every electron into the E, the energy will be decreased by minus 0.6 delta T. Okay. So for every electron entering into the E orbital, minus 0.6. For every electron entering into the T2, the energy will be increased by 0.4. I will give you D1, D2, D3, D4, D10 configurations in weak field, strong field in coming videos. Okay, you can check all those videos for what is the crystal field stabilization energy, what is the pairing energy, when the pairing is taking place, all that points we will discuss there. Okay. And if you want to see the comparison between delta O and delta T, it's very simple. Delta O is 2.25 times greater than delta T. So delta O is 2.25 times delta T. Or we can say delta O is equals to 9/4 delta T. The important point here is ligands are approaching between the axes. So the orbitals between the axes will be experiencing more repulsions, and their energy will be more. They are called T2 orbitals, and these orbitals are called E orbitals. Crystal field splitting, that is in tetrahedral, coordination number 4. It is exactly opposite of coordination number 6. Signing off, Lucky sir.